Router 9 has got some networks, and we are going to use those attributes to reach those networks in a different path. For that, we will have some policies. We'll have some assumptions. We'll assume that we need to send the packet via that router instead of this router. That becomes our policy in path selection. Currently, if you see router 5, show IPBGP. I don't see my network. We need to verify why. Show IPBGP. I do have neighborship with 4444, which is IBGP. I'm not learning any routes from router 8. Okay, now I got it. I got one route. Okay, now I think I have everything that I want. Show IPBGP. If you see, the packets are going via router 3. The path taken to reach router 9 is via router 3. Why it is not going via router 2? We got route via both router 3, router 2, and also via router 4. Let me show you by using a pen. So this router says I'll go this way in order to reach these networks. But it can also go via this way. It can also go via this way. So first of all, we need to understand why by default it goes via this way. That's our first discussion is going to be. Why it's not going via router 1 or 2? Why should it go via router 3? Reason is this is EBGP, whereas if it needs to go this way, it is IBGP. EBGP is preferred over IBGP. This is attribute number 7. After MED, EBGP preferred over IBGP is one of the attributes. But why it is not going via router 2? Router 2 is also an EBGP. Why it should go via router 3 EBGP? This is the oldest one. This is the one which came first to inform about these networks. That's one reason. Before that, the router ID, when router 5 compares the router ID of router 2 and router 3, router 3's router ID is bigger than router 5. Than router 2. The loopback interface address or the physical interface address is always taken as the router ID. So according to router 2, its router ID is 123.123.123.123.2. Whereas this one is 123.123.123.3. Let me show you the router 5. Show IPBGP. There you go. Too many neighbors, so it is too many pages. So we'll go now to the top. This is for router 8, I don't want to see for router 8. This is for router 3, I do not want. This is for router 2. Router 2 is where? Yeah, this one. Okay, router 2 has got a router ID. I have configured a loopback on router 2, just take it. Good. Likewise, then router 3, we do have 3333. So the router 4 will have 4444. Where is the neighbor router 3? 333. The biggest router ID is always preferred. Let us now go back again to the BGP, show IP BGP in router 5. Show IP BGP. And take one network, for example, 192.3.1. If you see the hop count, AS path is 2. Just 2 hops on all the paths. So there's a tie in the AS path. Weight is also a tie. Why only here 100? Because it is IBGP. 4444, router 4 is an IBGP. Router 4 is an IBGP. Local preference is only for IBGP. So if you see from the attribute in sequence, there is tie-in weight, which is the very first attribute. Sorry. There is a very important constraint. Before you start seeing attribute, you need to see this next hop. All these three are valid, reachable, next hop. So then there is a tie again. What tie? All three are valid and reachable. There is none which is invalid. If it is invalid, it would have rejected there only. All three are reachable. So there is a tie in the next hop. All three are valid and reachable. And then the very first attribute is weight. Weight is locally significant to the router. We have not set any weight. That is why all are 0. After weight comes the local preference. Here I have local preference 100 for this. But for this too, I don't have any local preference. Because these networks are coming from outside. It won't focus on this IBGP given routes. The local preference will not be having any impact. These networks, if they are coming from local, then it will have an impact. So these networks are coming from outside. So based on the local preference, only the outgoing is impacted. That is true. The one with the higher local preference is preferred, but you don't have IBGPs. Only one IBGPs. You don't have an IBGP to compare and decide, and moreover, this is external network. So local preference cannot impact here. After local preference comes the origin. None of them are originated from the local router. All are coming from different router. If it is locally advertised, then you will have 0000. That will be preferred. When the origin code is I, there is a tie. All are advertised. All neighbors are giving this route, which is advertised in router 9. None of the neighbor gives question mark. If this would have given question mark, it would have ignored this gateway and skipped to this gateway. I would like to show you that. You see, I'm going to make the route coming from R3 as question mark. Hmm. Local preference is whenever you got two paths via IBGP. See, you got only one path via IBGP, rest are EBGPs. When you got more than one path via IBGP, only then it will compare which one has got the higher local preference and go via the higher local preference. But here when you have EBGP, they don't give focus to IBGP. They don't focus on, there is nothing to compare here. There is no multiple IBGP path. Always, when you have an EBGP path, it will always give importance to that EBGP path. So here itself it got ignored and it gives preference to this two. And when it gives preference to this two, it prefers this path because this router ID is bigger. But before the origin code is compared, origin code is also a tie. Today what I'm going to do is I'm going to change the origin code coming from router 3 so that router 5 will shift the greater than symbol to router 2. Right now it shows the best path as router 3, show IP route 999.9921. That is our focus. This is the only network we want to focus. This only network, I want to push it to router 2. Can we do this? Yes, we can do it by using route maps and prefix list. Let us write this prefix in the prefix list first. I'll go to router 3 and I say IP prefix list. Give any name. I'll say for what network? Okay. 2.1. Just one name. And then permit. And then this is the network /32. So we got a prefix list. We need to call this prefix list in the route map. Route map. I can give the same name, nothing wrong. Match IP prefix, match IP address prefix list. This. If match is found, set origin incomplete. Hence, I'm making it as question mark. And now what I'll do is I'll go to router BGP 33. Do show IP BGP summary. You see, this is the neighbor. I say neighbor. When you advertise the network to the neighbor, use the route map called this. when you advertise the updates out to this guy. Now, one more thing I need to add is show route map. You see, I said if you match with this access list, you do this. What if the match didn't happen? For those updates which don't match, I don't want to do any changes. So I need to create another route map, just namesake, and exit from there. Now if you see show route map, you have sequence 20 with for the rest of the traffic, for the rest of the updates. After saying this, clear IP BGP star soft, I'm just refreshing. Let us now go to router BGP. See, I did not disturb BGP. Without disturbing BGP, I have done some changes. Our focus is on 2.1. You see, because 3 has got question mark. Only 3 has got question mark, 35.3. For 3.1, there is no question mark in 35.3. For 4.1, there is no question mark in 25. Whatever. So there is no question mark here, but only for one network we twisted the origin. So it has shifted from here to here because the origin code is the tiebreaker. And check the routing table now. Show IP route. Oh, it's going via 25.5. Let's see. Show IP route BGP. Show BGP. For everything it has shifted, no? For everything it has shifted via this way. Via 3. Let me clear BGP once. Clear IP BGP star soft. That's true. So when we see here in this presentation, when there is a tie-in wait, it goes to local preference. When there is no local origin, it checks the shortest AS path and the origin code. So according to the origin code, it should have taken a decision to go via I instead of question mark. So it has decided to go via I. That's fine. That is seen for that network which we are speaking. It goes via I, much appreciated. But why should it go via this two, not via this one? For that, see, there is a tie in I, no MAD, prefers eBGP path over IBGP, that's not a problem. Prefers the path closest IGP, that is not the problem. Prefers the oldest route, this is the problem. You know, I refreshed BGP here in R3, R5. I correct in R3. I refreshed BGP in R3. So that as per the R5's timer, because I refreshed here, this became renewed and it became latest one, means not oldest one. This is the oldest. So according to the time of learning the routes, route learned from router 2 is older than the route that I received from router 3 because I refreshed on R3. You understood the problem? Not the problem. You understood the reason? Hello. Sai, are you there? Prefers the oldest. I'm not able to hear you. I think you are in mute. Prefers the oldest route for EBGP path.